Our sun is the heart of our solar system. It gives us light, warmth, and energy, making life on Earth possible. Every living thing, from the smallest plants to the largest animals, relies on the sun for survival. It sustains ecosystems, fuels weather systems, and creates the conditions that allow life to flourish. But while we are accustomed to the sun's predictable and life-giving nature, its behavior is far more volatile and complex than we might think. The sun has a side that can be powerful and, at times, dangerous. A side that can send waves of energy hurtling toward Earth, changing the course of our technological world. This is the phenomenon of solar flares. A solar flare is a sudden burst of intense energy released when the sun's magnetic fields suddenly reconnect in an explosive way. These massive releases of radiation can last anywhere from minutes to hours, and in some cases, the energy released is equivalent to millions of nuclear bombs exploding at once. These bursts of energy can travel across space at the speed of light, reaching Earth in just a few minutes, where their effects can be felt almost immediately. Earth's magnetic field acts as a protective shield, deflecting much of the sun's harmful radiation and protecting life from the intense solar wind. This shield is strong enough to absorb most solar radiation, but when the intensity of a solar flare increases, it can overwhelm this magnetic protection, causing what we call a geomagnetic storm. These storms are like massive waves traveling through the atmosphere, affecting everything from our power grids to our communication systems, and in extreme cases, even astronauts in space. The impact of a solar flare on Earth can be profound. Satellites, which are integral to modern life, can be severely affected. Solar flares can damage the delicate electronics aboard satellites, leading to communication failures, GPS disruptions, and even the loss of satellite services for days, weeks, or even longer. These satellites play a critical role in global communication, weather forecasting, and navigation. Disruptions to them can send ripples throughout the entire global economy. But it's not just satellites that are at risk. The most immediate and concerning threat to us here on Earth is how solar flares can affect our power grids. When high-energy particles from the flare reach Earth's magnetic field, they can induce electric currents in long power lines. These geomagnetic-induced currents can damage electrical transformers and cause widespread blackouts. A strong solar flare, known as a coronal mass ejection, could potentially disrupt power across entire continents, leaving millions without electricity for extended periods. To prepare for such an event, it's important to stay informed. Solar flares, like other natural disasters, are unpredictable in their timing and strength, but they follow patterns and can be tracked. Scientists at NASA, NOAA, and other agencies monitor solar activity and use sophisticated instruments to predict solar flares before they reach Earth. There are apps and websites that provide real-time updates on solar flare activity, giving us the tools to anticipate potential disruptions. Preparation is key. While we cannot control the sun, we can control how we respond to its outbursts. The first step in preparing for a solar flare is having an emergency plan. This includes ensuring that you have essential supplies, water, non-perishable food, medications, and first aid supplies on hand in case a flare causes a long-term power outage. It's also a good idea to keep flashlights, extra batteries, and portable chargers ready in case the lights go out. One of the most vulnerable aspects of our daily lives is our electronics. Solar flares release a powerful electromagnetic pulse that can damage or even destroy the sensitive electronics we rely on. To protect your devices, consider investing in a Faraday cage or Faraday bag. These protective enclosures block electromagnetic radiation, ensuring that your phones, laptops, radios, and other important devices are shielded during a solar event. For those managing critical infrastructure, preparing for solar flares means fortifying power grids and communication systems. Utilities can install surge protectors on transformers and other essential equipment to prevent geomagnetic storms from causing damage. Some regions may even preemptively shut down vulnerable parts of the grid when solar flare activity is high, reducing the risk of long-term damage. In the event of a solar flare, the loss of power can also disrupt our ability to communicate. Cell towers, internet routers, and communication satellites could all be impacted. However, in situations like this, traditional communication methods, like battery-powered radios, become crucial. These low-tech devices can keep you informed about emergency alerts, evacuation routes, or power restoration efforts, even when other forms of communication fail. Fortunately, scientists aren't waiting idly for the next solar flare to strike. Space agencies, including NASA and the European Space Agency, are monitoring the sun's activity around the clock. Their goal is not only to predict solar flares more accurately, but also to understand the sun's complex behaviors so we can better shield our technologies. With advanced spacecraft like the Parker Solar Probe, which is studying the sun up close, we are gaining unprecedented insights into solar activity that will help us prepare for solar storms in the future. But preparation doesn't stop with experts and emergency responders. Everyone can contribute to greater resilience by understanding solar flares and their effects. It's critical that we educate communities about the importance of solar flare preparedness. Schools, hospitals, businesses, and local governments should have comprehensive plans in place for such events, and individuals should know how to protect themselves and their property. Beyond Earth, the potential impact of solar flares extends to our ventures in space. Solar radiation poses a significant threat to astronauts aboard the International Space Station or any spacecraft venturing beyond Earth's atmosphere. Solar flares can cause radiation exposure that is harmful to human health. Space agencies have developed protocols to protect astronauts during these solar events, such as moving to shielded areas of the spacecraft or halting extravehicular activities during solar storms. Despite the dangers, solar flares also have their beauty. When the charged particles from the sun collide with Earth's magnetic field, they can create the dazzling light displays we know as the aurora borealis, or northern lights. While these beautiful phenomena are a sign of the sun's powerful activity, they also highlight the interaction between the solar wind and our planet's protective field, a sign of both the sun's power and the resilience of our planet. The sun is both a source of life and a powerful force that reminds us of our vulnerability. As we continue to rely on increasingly complex technological systems, we must recognize the risks posed by solar flares and take steps to prepare for them. The future of space exploration, global communication, and our energy infrastructure all depend on our ability to adapt to the sun's unpredictable behavior. By staying informed, protecting our electronics, and taking steps to ensure our communities are prepared, we can face solar flares with confidence. The sun may be unpredictable, but our response doesn't have to be. Knowledge is power, and preparation is our best defense against the sun's unpredictable outbursts.